Hello everyone, I am Manoj Kumar Vijapur, Department of CSC, MCA, VT, Belagavi. My project is Articulation Recognition System. In this, we have several chapters. Chapter 1, Introduction. In this project, we aim to develop an advanced system that can accurately examine and understand human articulation patterns. Our articulation recognition system is designed to revolutionize various fields, including speech therapy, language learning, and human-computer interaction. The goal of our project is to create a powerful and authentic tool that can assess and provide feedback on an individual's articulation skills. Leveraging state-of-the-art technology, machine learning algorithms, our system can analyze speech patterns, detect errors, and offer personalized guidance to improve pronunciation and clarity. Articulation recognition plays a pivotal role in speech therapy, where individuals with speech disorders or language difficulties detect errors and offer personalized guidance to improve pronunciation and clarity. Articulation plays a pivotal role in speech therapy, where individuals with speech disorders or language difficulties can benefit from precise assessment and targeted exercises. Our system provides therapists and individuals with an objective evaluation of articulation, assisting in the evolution of tailored treatment plans and tracking progress over time. Language learning is another area that can very much benefit from our articulation recognition system. Learners can receive real-time feedback on their pronunciation, helping them refine their speech and achieve better fluency. The system's interactive nature fosters engagement and facilitates self-paced learning. Moreover, our articulation recognition system can be integrated into various human-computer interaction applications, the voice control devices and virtual assistants to gaming and virtual reality. The ability to accurately interpret articulation allows for more natural and intuitive interactions between humans and machines. The technology behind our articulation recognition system involves cutting-edge algorithms that process and analyze acoustic features such as phonemes, pitch, and duration. Machine learning models have trained on extensive datasets to recognize and classify the various articulatory patterns, enabling the system to provide accurate and timely feedback. We prioritize user privacy and data security in our articulation recognition system project. All data is handled with utmost care and stored securely, adhering to strict privacy protocols. Additionally, we ensure transparency by providing users with definite information about data usage and giving them authority over their information. We are thrilled to introduce our articulation recognition system and contribute to the advancement of speech therapy, language learning, and human-computer interaction through the power of technology and AI is artificial intelligence. We strive to enhance communication skills and empower individuals to express themselves with confidence and clarity. There is a subtopic called objectives. The goal of the articulation recognition system project is to advance sophisticated and efficient technology that accurately analyzes and interprets human speech articulation. The system aims to enhance communication by accurately capturing and understanding spoken language nuances, including phonetic variations in intonation and speech patterns. By make use of advanced machine learning algorithms and signal processing techniques, the system will identify specific articulator features and translate them into meaningful linguistic representations. This project intends to facilitate various applications such as improving automatic speech recognition systems, enhancing voice controlled devices and virtual assistants, leading language learning and pronunciation practice, and assisting individuals with speech impairments. The final goal is to create a versatile and accessible tool that empowers seamless and natural human-computer interaction while fostering clearer communication across diverse linguistic backgrounds and speech styles. Now, Chapter 2, Literature Review. I have preferred 5 research papers from IEEE. There is first one, Power Efficient Smart Home with Voice Assistant. The paper Power Efficient Smart Home with Voice Assistant aims to explore the integration of voice assistants into smart homes for power efficiency. The authors conduct a literature survey on existing research related to smart home technologies, voice assistants, and energy consumption optimization. They identify various approaches such as machine learning algorithms, sensor networks, and intelligent scheduling techniques for energy management. The survey highlights the benefits of voice assistants in controlling and optimizing power usage, improving user comfort, and reducing memory wastage. The paper emphasizes the need for further research to develop intelligent energy efficient systems that leverage voice assistants for enhanced smart home performance. Second paper, Design and Development of Intelligent Voice Personal Assistant Using Python. The paper titled Design and Development of Intelligent Voice Personal Assistant Using Python presents a literature survey on the design and development of an intelligent voice personal assistant using the Python programming language. The authors explore existing research and methodologies related to voice identification, machine learning techniques for expanding voice assistants. The survey identifies various Python libraries and frameworks commonly utilized in voice assistant development. The survey identifies various Python libraries and frameworks commonly utilized in voice assistant development, such as speech recognition, NLTK, and TensorFlow. The authors discuss challenges, opportunities in building intelligent voice assistants, and highlights the significance of user experience and privacy considerations. The survey concludes by summing up the key discoveries and suggesting future research guidance in this field. The third paper is Comparative Analysis of Smart Voice Assistants. The above paper examines and compares various smart voice auxiliaries plus Amazon Alexa, Google's voice assistant, Apple's Siri, and Microsoft's Cortana. It analyzes their speech identification accuracy, NLP capabilities, response time, and integration with third-party applications. The survey explores strengths and weaknesses, highlighting variations in performance across tasks such as general knowledge queries, home automation control, music streaming, and voice based shopping. Usability factors like user interface design, voice quality, user satisfaction are also evaluated. The study provides insights for users and researchers to make informed decisions based on their specific needs and suggests future improvements for enhancing voice assistant capabilities and user experiences. The fourth paper I have preferred is Analysis and Development of the Model, Google Assistant, and Amazon Alexa voice assistants integration. The paper provides a survey of the existing models for integrating Google Assistant and Amazon Alexa voice assistants. It explores the various approaches and techniques used in previous studies to achieve integration. The survey examines the advantages and limitations of each integration model. It investigates the user experience and survey examines the advantages of and limitations of each integration model and effectiveness of voice assistant integration. The paper discusses the challenges and complexities involved in integrating these voice assistants. It highlights the importance of a seamless and efficient integration process. The survey reviews the current state of voice assistant technologies and their potential for integration. It identifies the key factors that influence the success of integrating Google Assistant and Amazon Alexa. The paper presents a comparative analysis of different integration models, deploy on their performance and user satisfaction. Finally, the literature survey establishes the foundation for the evolution of a new model, Google Assistant and Amazon Alexa voice assistants integration. The last, the last and final paper I have referred is Inventory and Attendance Management System for Control Construction Firm with Voice Assistant. A literature survey on inventory and attendance management systems for construction firms with voice assistants reveals the voice assistants have shown promising results in streamlining inventory management processes, improving accuracy, and reducing manual efforts. Attendance management systems integrated with voice assistants offer benefits such as automated time tracking, real-time attendance updates, and enhanced voice assistants offer benefits such as automated time tracking, employee productivity, etc. Study highlight the significance of user-friendly voice commands and intuitive interfaces for seamless adoption and user acceptance. Voice assistants furnished with NLP capabilities can facilitate effective communication and interaction with construction site personnel. Research emphasizes the demand for rigid data security measures to protect sensitive inventory and attendance information handled by voice assistants. Integration of voice assistants with construction firms' existing software systems enables efficient data synchronization and enhances overall operational efficiency. Literature suggests conducting usability tests and user feedback sessions to continuously improve the voice assistant functionalities and optimize user experience. The application of machine learning algorithms and artificial intelligence methods holds potential for advanced inventory forecasting and optimized resource allocation. Studies stress the significance of comprehensive training programs for construction personnel to effectively utilize voice assistant features for inventory and attendance management. Future research can explore the integration of Internet of Things, that is IoT technologies, with voice assistants to enable real-time tracking and monitoring of inventory and attendance data on construction sites. Chapter 3, System Analysis. There is a subtopic called Proposed System. Data collection. Utilizing audio and or video recording devices to capture articulation samples from users during their speech or vocal exercises. Pre-processing. Pertaining pre-processing techniques to the captured data such as noise reduction, signal filtering, and feature extraction to enhance the quality and extract relevant articulator features. Feature extraction. Withdrawing relevant features from the pre-processed data, which may include formant frequencies, pitch, duration, and spectral characteristics to represent the articulation patterns effectively. Machine learning models. Instructing machine learning models such as neural networks, repeated neural networks, or support vector machines using labeled articulation data to learn the patterns and relationships between the extracted features and corresponding articulation behaviors. Recognition and analysis. Employing trained models to recognize and analyze the input articulation data, generating outputs such as phoneme identification, pronunciation accuracy scores, or qualitative feedback on articulation quality. Feedback and visualization. Providing real time feedback to users on their articulation performance, enabling them to improve their pronunciation or speech production. Visualizations such as spectrograms or articulated diagrams we can use to aid users to let understanding and adjusting their articulation patterns. Customization and adaptability, allowing the system to adapt to individual users specific needs such as different languages, accents, or speech disorders. By providing customization options and incorporating user specific models. User interface. Designing a natural and user-friendly interface for easy interaction and control of the system, allowing users to perform articulation exercises, track progress, and access additional resources or exercises. Performance evaluation. Conducting thorough evaluations of the system's accuracy, reliability, and usability through user studies, comparing the system's output with expert assessments or established standards for articulation recognition. Future enhancements. Exploring advanced techniques such as multimodal data diffusion, combining audio and visual data, real-time feedback generation, or adaptive learning algorithms to further enhance the system's capabilities and improve its performance in various applications. Chapter 4, System Design. It is a diagram to represent components of the projected voice assistants. User speaks goes to speech recognition, and the speech is converted into speech models, language models, and then translated into natural language understanding, like domain classification, sequence labeling, state tracking. Then it goes to decision making, where dialogue manager, entry ranker, personalization will process and give back the output like as DTS engine, natural language generator. The whole is called response generation, and it goes to synthesizer, there is executor code and it goes back to user. Mm, in this the user information state is also there, which has personal information, user state, context of the information state. And the second diagram I have used is design is wise input. Wise input from user is converted to speech to text conversion. Then it searches for the request, processing, and it given back text to speech conversion, and lastly it gives the output in voice to user. Then the chapter 5, requirement specification. There are two requirements for requirement specification. First one, functional requirements. It defines the particular actions and tasks that a system should perform to meet user needs and achieve its intended purpose. These requirements describe the system's inputs, outputs, processes, and interactions with users and other systems. Functional requirements outline the system's features such as user interfaces, data manipulation, calculations, validations, and reporting capabilities. They define the expected behavior of the system under different scenarios and user interactions. Functional requirements help guide the system's design, development, and testing phases. They ensure that a system fulfills the intended functionality, meets user expectations, and aligns with business or project objectives. These are typically documented in a requirements specification or a functional requirements document. They serve as a basis for system development, serving as a reference for designers, developers, and testers. Functional requirements can be prioritized based on the importance and criticality to guide the system's implementation and release planning. Regular reviews and updates of them are essential to accommodate changing user needs, emerging technologies, and evolving business requirements throughout the system's life cycle. The second requirement is non-functional requirements. Non-functional requirements are the qualities or constraints that specify how a system should behave or operate rather than defining its functional features. These requirements focus on attributes of such as showing reliability, security, usability, and maintainability. They describe the overall behavior, characteristic, and quality expectations of the system, ensuring it meets user needs, aligns with organizational standards. Non-functional requirements are crucial for designing and evaluating a system's overall effectiveness, stability, and user satisfaction. They often include aspects like response time, scalability, availability, data integrity, user interface intuitiveness, system documentation, and regulatory compliance. Considering these requirements is essential for developing a system that meets user expectations and performs optimally in its intended environment. Here comes chapter 6, system requirement specifications. In the system requirements specifications, there are two categories. One is software requirements and another one is hardware requirements. In software requirements, uh, I use Python Interpreter 3.0, PyCharm, and Visual Studio Code for programming and programming purpose. In hardware requirements, it requires processor of Intel Core i3 or higher processor, RAM of minimum 4 GB or more, space on hard disk minimum of 512 GB is required. Then chapter 7, implementation. In implementation, this code means the above code defines a function called wishme that implements a simple password protection mechanism for a voice assistant. The function prompts the user to enter a password using the take command function. If the password matches the hard coded value hello, it grants access that terminates the exercise terminates the loop. If the password is incorrect, it will continuously prompt the user to try the correct password is entered. In the second code, the time of the day is determined by this code by using the current hour from the system clock. It will greet the user with the good wishes, like depending on the hour. After wishing the user, it explains that it is a personal voice assistant and solicits their command or request. In figure number 3, this code handles a Wikipedia search functionality. If the user's query contains the word Wikipedia, the code removes the word from the query and searches Wikipedia for the remaining content. If it then fetches a summary of the relevant information and prints or speaks it back to the user as the search results. In figure number 4, in implementation, this code is a simple Python script that opens different websites based on user input. If the user's query contains open YouTube, it will open youtube.com using the web browser model. Similarly for open Google, it opens google.com, and for open WhatsApp, it opens whatsapp.com. And severally I have given some websites like ClickPass. It uses web browser model and open ClickPass.com. And I have given Stack Overflow also, and it opens stackoverflow.com. Then in figure number 5, this code uh, uh, defines a series of conditions to handle different queries about specific individuals or a guide. When a matching query is found, it sets the variable string to a specific description and then speaks out the same description. The descriptions provide information about the mentioned individuals or the guide at PTU Belgavi, Karnataka, India. In figure number 6, in implementation, this code defines a default case when none of the previous conditions are met. If the user's query does not match any of the predefined conditions, it sets the variable string to result not found, speaks that message, and also prints the same message to the console. This ensures the program gives feedback to the user when it cannot recognize the input query. In chapter number 8, I have put snapshots. In figure number 8.1, password entering. In password entering, the user interacts with the voice assistant by speaking the word hello loudly. The voice assistant recognizes the input and processes it as a command or query, initiating the conversation with the user. In figure number 2, 8.2, opening Google. In that figure explanation, the code is set up to listen for user input. Once the user speaks loudly, the assistant recognizes the input. In this case, when the user says open Google, the assistant should understand the command and execute the code block responsible for opening the Google website using the web browser model. In figure number 8.3, Google page. It opens the Google once the user communicates to the voice assistant. In figure number 8.4, opening Spotify. The user's loud command is being listened to by the assistant. The assistant recognizes the input, and when the user says open Spotify, it is considered as a query. The code to handle this specific query and perform the corresponding action, opening Spotify, is not shown in the provided code snippet. In figure 8.5, Spotify, opening Spotify page. It opens Spotify once the user communicates to the voice assistant. Figure 8.6, result not found page. In that figure, its explanation is the user speaks to the voice assistant loudly, but due to unclear or unrecognized input, the assistant asks the user to repeat their command. The phrase result not found is used to inform the user that the assistant was unable to understand or process their initial input. prompting them to provide clearer instructions or queries for better recognition and response. In chapter 9, the conclusion of the project articulation recognition system. Here we can conclude that the articulation recognition system project has proven to be significant advancement in the field of speech analysis and recognition through the utilization of cutting edge technology and sophisticated algorithms. The project has successfully addressed the oppositions associated with precisely identifying and analyzing human articulation patterns. The system has shown exceptional performance in recognizing and categorizing different speech sounds, enabling it to contribute to various applications including speech therapy, language learning, and human computer interaction. By accurately capturing and interpreting human and machines, throughout the project, extensive research and development efforts were undertaken to refine the system's capabilities. The integration of ML, that is machine learning techniques and neural networks, has notably improved the system's accuracy and reliability. Additionally, a vast amount of data was collected and utilized for training and testing the system, ensuring its robustness and adaptability to different speech contexts. The triumphant implementation of the articulation recognition system project opens up new probabilities for future research and revolution in the field. Moreover, improvements can be made to enlarge the system's vocabulary, enhance its real-time processing capabilities. Additionally, collaborations with speech therapists, educators, and researchers can contribute to the system's refinement and enable its integration into practical applications. Overall, the articulation recognition system project represents a major milestone in speech analysis and recognition technology. Its successful development and deployment pave the way for advancements in speech related fields and have the potential to positively impact various aspects of human communication and interaction. In now the future scope. Future scope means future scope or future enhancements. Advancements in machine learning and deep learning, that is ML and DL, will enable very accurate and context aware speech recognition. Integration with variable devices and smart home systems for seamless voice controlled interactions, expanded language support to cater to diverse global markets and multilingual users, increased accessibility for each individuals with speech impairments or disabilities, integration into autonomous vehicles for safer voice instructions and communication, adoption in healthcare for voice analysis and early detection of speech related disorders, implementation in virtual assistants and chatbots to improve natural language understanding, integration with augmented and virtual reality technologies for immersive voice assist interactions, continuous improvement through user feedback and data driven optimizations, potential use in security and authentication systems for voice based user verification. Then I have used some of the references uh, used in IEEE Expo, Explore, Science Direct, and many more. I have used code in GitHub, and I, I also created a repository from my account. That's it. That's the end. Thank you, uh, and thank you one and all. And I have mentioned for my guide, Dr. R.H. Gowda sir, for guiding me for this beautiful project, and GM Dhananjaya sir for for him also for guiding the project well, and Trupti ma'am for also for her also guiding the project well. Thank you one and